Good morning friends. Welcome back to Parnika tutorials. In the last video, I have discussed about the double-ended queue and its applications. I hope you have watched that video. If you did not watch that video or if you don't know those concepts, I request you to go back and watch that video and come back to this video. In this video, I want to discuss how to implement the double-ended queue using the arrays. So I request everyone to watch the complete video for better understanding. First, let me discuss about the basics of queue. Then I will discuss how the queue is different to the double-ended queue. Then I will discuss how to check the double-ended queue is full or empty. Then we will discuss various operations on the double-ended queue. You know that queue is a linear data structure where the operations such as enqueue, dequeue, display will be performed in a certain order. What is that order is? The queue follows the first in first out principle or last in last out principle, and we have the two operations. One is the enqueue. Enqueue is inserting an element into the queue, and also we have the dequeue, which is deleting an element from the queue. And we will have two variables called front and rear. Front will be pointing to the first element in the queue and rear will be pointing to the last element in the queue. Suppose let's take that you have elements 2, 3, 4, then 2 will be pointed by the front and 4 will be pointed by the rear. If you want to insert any element, you will increment the rear, then you will insert the new element, so rear will be pointing here. If you want to dequeue an element from the queue, then you will increment the front, then logically we have deleted this element. Now front is here and rear is here. If anyone asks you to display the elements which are there in the queue, you will start from front and you will go up to rear. So this is about the queue. Now let me discuss about the double-ended queue, which we will call it as dequeue. Now the basic difference between the queue and the double-ended queue is, in the double-ended queue, we can perform the enqueue operation and dequeue operations at both the sides. Meaning is that we can perform the enqueue, dequeue at the rear and also enqueue and dequeue at the front also. Is it clear? Are you able to understand? When it comes to the queue, enqueue can be done at the rear and dequeue can be done at the front. But when it is coming to the double-ended queue, we can perform both the operations at front and rear. Okay. So what are the operations we can perform? I hope you have understood. Now let me discuss what is the condition to check the double-ended queue is empty. Now when we implement this double-ended queue using the arrays, you know that always the array index will be start from 0 and go up to size -1. Okay, is it clear? Are you able to understand it or not? Now if you are implementing the double-ended queue or stack, we will only use the top pointer. When it comes to the queue, circular queue or double-ended queue, we will make front and rear is equal to -1 initially. If front and rear is equal to -1, then we can say that double-ended queue is empty. Is it clear? So this is the condition to check whether the double-ended queue is empty or not. Now coming to the double-ended queue, whether it is full or not, how can we check? Let's take that we have inserted the elements 20, 30, 40, 50, 60. Now this is the first element we have inserted. So front is equal to 0 and this is the last element, so rear is equal to size -1. For your understanding, let's take that size is 5, so size -1 is 4. Now rear is equal to 4. Now as the array size is 5, if you are implementing the double-ended queue using the array of size 5, you can insert only 5 elements. Already you have inserted all the 5 elements. Now you can say that double-ended queue is full. So the condition for checking the double-ended queue is full is that if front is equal to 0 and rear is equal to size -1, then also you can say that double-ended queue is full. Whether any other condition is there? Yes, let me discuss it for you also. Now rear is equal to 4. Now Okay, front is equal to 0. What you have done is that you have performed the dequeue, dequeue, dequeue 3 times. Now front is here, am I right? Okay, you have started dequeuing the from the front. It is possible. Okay, so front is equal to 3 and rear is equal to 4. Now someone has asked you to Enqueue at the rear, means that you want to insert the element after the 60. Now rear is equal to 4. Whenever we want to perform the Enqueue operation at the rear, meaning is that inserting at the rear, we need to increment the rear value. If I increment the rear value by 1, rear will become 5. Whether a array of size 5 will have the index 5? No, it is not possible. If it is not possible, can I say that double-ended queue is full? No. These positions, the values are not there. Logically, we have deleted them. Is it clear? So, what I can do is that I should make rear is equal to 0 and start inserting the elements. That is what we have done in the circular queue also. When it is rear is equal to size minus 1, we have incremented the rear, like rear. If it is queue, we will say rear plus plus, but when it comes to the circular queue, rear is equal to rear plus 1 modulus size. So rear is equal to 4, 4 plus 1 modulus 5 will become 0. So at that index, I will insert the element 70. Then I started inserting 80, 90. Now rear is equal to 2 and front is equal to 3. Now can I say that double-ended queue is full? Yes, all the elements were inserted. Now also I can say that double-ended queue is full. So even this or front is equal to rear plus 1, then also I can say that double-ended queue is full. So for empty, front is equal to minus 1 and rear is equal to minus 1, then I can say that double-ended queue is empty. When I can say that double-ended queue is full, if any one of this condition is true, then I can say that double-ended queue is full. So I hope you have understood these two conditions. If you have understood these two conditions, let me discuss the how to insert an element at the front, how to insert an element at the rear, meaning is that enqueue operation. Similarly, dequeue at the front, dequeue at rear, all these things I will discuss in detail. Okay, let me erase this one so that I will use this space to write the program for you. Okay, I hope you are enjoying with the video. If you're really enjoying the video, I request you to please press the like button, and if you want to give any feedback, I request you to give it in the comment section. Now let me erase it, and also please share the video with your friends. But first thing first, you completely watch that video, then only you share the video with your friends. First yours, then your friends. Okay, is it clear? Now let me include the header files hash include stdio.h, hash include stdlib.h. okay, then I will define a macro, okay, size with constant 5. Then I will declare an array called dequeue of size. Okay, then I'm declaring two variables called front, which are global variables. I think you know what is meant by global variables. If it is global variables, you can access them in the entire program. Front and rear, I have made them as -1. Now what I will do is that I will discuss the logic behind insert at front. Void, this is the function return type. So this function does not return any value, and the name of the function is enqueue at front, because we are using the concept called queue. So instead of using the insert, we should say front. Now whenever you are inserting, you need to take a variable, ask the user to enter some value. Okay, then you can read that value using the scanf function. As we are reading an integer, let me write %d and %x. After that, you need to check whether the queue is full or not. How can you check the queue is full or not? If front is equal to 0 and rear is equal to size -1, or front is equal to rear plus 1. If any one of this condition is true, we will say that double-ended queue is full. You can write simply full. If you want to write what is full, you can completely write it. You can write it double-ended queue is full. Else if, meaning is that double-ended queue is not full. If double-ended queue is not full, let's take this scenario. The double-ended queue is empty. When I can say the double-ended queue is empty? If front is equal to -1 and rear is equal to -1, then double-ended queue is empty. Now whatever the element you are inserting, that is the first element. You want to insert at front, Enqueue at front. So the array index will start from 0 and go up to 4 in your case. Then the first element, let's take the 20. If you insert, then this is the first element and this is the last element. Am I right or wrong? So in that case, what you have to make, front is equal to rear is equal to 0, and at index front you need to assign the value. So else if front is equal to -1 and rear is equal to -1, then what we will do is that we will make front is equal to rear is equal to 0, and the array called dequeue at index front, we will assign the value x. Is it clear? Which is a variable. Whatever the value is there in this variable, we will assign it. Else if, is it clear? Now let's take that you have inserted the element 20. Now front and rear, let me write it as f and r. Now front is equal to 0, rear is equal to 0. So this front and rear is pointing to this one. Now someone has asked you to enqueue at front, meaning is that before 20 you need to enqueue one element or insert an element. Is it possible? Yes, it is possible, because it is a double-ended queue. At both the sides we can perform the enqueue operation. Now if I say I want to insert some element here, suppose let's take the 10 I want to insert. Now what we will say, at index -1 you need to insert. But array consists of index -1. No, that is not possible. Then if you cannot insert at the index -1, can you say that double-ended queue is full, so that's why I cannot insert? No, these are the empty locations. So what we have to do is that if front is equal to 0, okay, if someone has called enqueue at front, then what you have to do is that, as it is a circular array, is it clear? What is meant by circular array? This is index 0, okay, this is index 1, this is index 2, this is index 3, this is index 4. So you are at the index 0. Front means this will become. Is it clear? Front of this one. Before this you have to insert. So at index 4 you need to insert. So else if front is equal to 0, okay, then what you need to do is that you have to make front is equal to okay, size -1, okay, and in the array called dequeue at index front you need to assign the value. Is it clear? So this is else if. Now let's take that you have inserted 30. Now rear is equal to 0, front is equal to 4. Now someone has asked you to again enqueue at front. So front is here. Before that you need to do. So what you will do? You will make front -. At that index 3 you will insert the element. So you will write else, okay, front -, okay, or you can write front is equal to front -1. Then in the array called dequeue at index front you will assign the value which is there in the variable x. You will close the else, you will close the function called enqueue at front. So suppose if user has entered 70, then front will be this one, okay. So this is the first element, okay, and this is the last element. Is it clear? Are you able to understand? If user has asked you to display, you should display as 70, 30, 20. Is it clear? So it is logically like this, 70, 20, 30, 20 it is there. and front is here and rear is here. That is what inserting at the front. Are you able to understand? Let's take that you are standing in a line. When you went to Tirumala temple, some VIPs will be there. You will be in the line. VIPs, if there is a particular time, they will go and visit the temple and they will come. So they will give the most priority. So here 70 and 30 are more priority than the 20. Is it clear? Just an example I am telling. Now let me discuss about the Enqueue at rear. This already we have discussed in the circular queue. Same way you can do it. So this part is same, this part is same, okay, only this part will change, okay. Meaning is that this condition is for the full, to check the double-ended queue is full or not. If double-ended queue is empty, here what you have to write, instead of front you should write at index rear, you need to do it. But however it does not vary, but they are asking Enqueue at rear. Let me write here rear only, so that everyone ego will be satisfied. Okay, is it clear? Now let me erase this else also. Okay, now let's take that these are the elements are there. Now someone has asked you to insert at the rear. Now rear is what? Rear is equal to 0. Are you able to understand? Rear is at here, front is equal to 0. Now someone has asked you to insert here. So that is our, what you will do, rear plus plus, then at the queue of rear we will do it. So I will write the else. Before that, after that I will discuss another else if condition. So as this example is there, I am using. So I will write rear plus plus, okay. Then in the array called dequeue at index rear, I will assign the value which is there in the variable x. But let me write the else if condition. Okay, let me assume that these all elements you have deleted. Okay, there is a rear here, rear is equal to 4. Okay, then some element 60 is there and front is here. Let's assume just something, but this is the main highlight. Front is equal to here with element some 30. Now someone has asked you to increment after the rear. So what you usually will do, rear plus plus. But if I do this rear plus plus, rear value will become 5. In an array of size 5, will you have at the index 5? No, it is out of boundary. So what you should do, can you say that queue is full? No, double-ended queue is not full. These are the empty positions. So then what you have to do, you have to make rear is equal to 0. So if rear is equal to size minus 1, okay, then we should make rear is equal to 0. In the array called dequeue at index rear, you need to assign the variable which is there in the value which is there in the variable x. Is it clear? So rear is becoming 0 and you are inserting element 70 here. Now again, if user has called the Enqueue at rear, then these three conditions will be failed. This condition will be true, means else block will be true. Suppose what you will do, rear plus plus, so rear value will become 1, okay. Then dequeue of rear at this index, let's take that x is having value 80, that value will be assigned here. So this is about the Enqueue at rear, Enqueue at the front. Now we will discuss about the dequeue, okay. Then we will discuss about the display, okay. Let me erase properly so that we can use this space to write the remaining program. See, maybe you can understand how hard it is difficult to teach, okay, and upload in the YouTube. Is it clear? So void dequeue, okay, at front. Usually we will dequeue at front in simple queue also. So same principle we can do here. But if you want to dequeue, first you need to check whether double-ended queue is empty or not. How you will check double-ended queue is empty or not? If front is equal to -1 and rear is equal to -1, then you will print empty. Double-ended queue is empty. If it is empty, how can you delete an element? You cannot delete an element. Else if you have only one element, you can say only one element is there. If front is equal to rear, let's take that you have performed dequeue all these things. Okay, now front is equal to 1 and rear is equal to 1. Only one element is there. Whenever front is equal to rear, only one element is there, otherwise it is empty. That condition we have checked. Otherwise we are saying front is equal to rear, then only one element is there. Then what should we do? If you delete that element, double-ended queue will be empty. So first we need to display the user that this is the element we are deleting. You can write whatever the statement you want to write, the deleted element or the dequeued element, all these things you can write. Then name of the array, and then at index front what is the value is that you need to display. Then you have to make front is equal to rear is equal to 0, sorry, not 0, -1. Then only double-ended queue is empty. So you have to delete this one and make this one front is equal to rear is equal to -1. So the double-ended queue is empty. Else if even this is also false, these two conditions are false, then what should I do? Now I want to delete at the front. Now let's take that there are some elements, okay, 30, 60 is there, rear is here at index 3, front is at the index called 4. Now you know the dequeue, what you have to do. When we are discussing about the simple queue also, if you have elements 2, 3, 4 like this, 5 is there, and front is equal to 0 and rear is equal to 3. Okay, if you say dequeue at front means you have to increment the front plus plus we will write, front will become 1. So logically this element has been deleted. Now if I apply the same principle, front plus plus, what will happen? Front value will become 5. Whether an array of size 5, do you have an index called 5? No, not possible. Always the array index will start from 0 and go up to size -1. If the array size is 5, it will be maximum up to 4. Can you say that it is empty? No, you cannot say. So what you will do is that you will make it as front is equal to 0. So logically you have deleted the element. Is it clear? Are you able to understand it or not? Okay. So else if front is equal to size -1, okay, then we will say that else if open printf %d dequeue at index front, okay, then you make front is equal to 0. Close the else if. If not, meaning is that, let's take that these are the elements like this, front is equal to 0, rear is equal to 2. Then none of these conditions will be true. That's what else will come. If like this, someone has called you dequeue at front, so from the front you have to delete it. So then what you have to do? You have to make front plus plus. So front will become 1. Logically you have deleted the element 20. So else, if none of this condition is true, you have to write else printf %d, this is the element you are deleting, like that you can write. Then you can write dequeue at index front, whatever the value is there that you will display to the user, okay, and then you will make front plus plus. Close the else, close the dequeue at front function. So this is the statements for dequeuing at front, meaning is the deleting an element from the front. Now dequeue at rear. Okay, now dequeuing at rear also, these conditions will be same, only these two parts will vary. So let me erase only these two things so that I can save your time and also my energy also. Okay, let me take some example. Okay, index 0 1 2 3 4, there are some elements are there, some 20 30 40, and front is pointing to 0, rear is pointing to 2. Now someone is called dequeue at rear. Dequeue at rear means from rear you need to delete. So which element you need to delete? 40. So how can you delete it? If you make rear is equal to 1, meaning is that you are doing rear minus minus, or you are writing rear is equal to rear minus 1. So 2 minus 1, rear will become 1. Then logically you have deleted this one. So from front to rear you are displaying the elements. Okay, so before that, or let me write the else block for you. Okay, then we will write the else if. So we have discussed about the else. Okay, printf, here we should not write the front because we are deleting at the rear, so here we need to change it to rear. Printf %d dequeue at rear, at the index rear, whatever the value is there that you are displaying, then you are making rear minus minus, or you can write rear is equal to rear minus. I am closing the dequeue function also. Before that, I need to discuss another condition. So else if I will write here. Now let's take that there is a scenario like this. 20 is there, 30 is there, and 40 is there. Okay, here front is there and here rear is there. Now someone has asked you to delete the element from the rear, so you need to delete the element 40. If you delete the element 40, if you write rear minus minus, is it clear? Then rear will become minus 1. Whether an array consists of an index minus 1, that is not possible. Am I right? Can you say that I cannot delete it? No, you cannot say it, because you can still delete the elements. There are 40, 20, 30 is there, you have to delete it. So what you can do is that if rear is equal to 0, okay, then what you can do is that again you display the element which you are deleting. In this case 40 will be displayed. Okay, dequeue of rear. Okay, close the printf and enter the semicolon. Then what you need to make? You need to make rear is equal to size minus 1. So rear will become 4 in this case, because the array size is 5. So 5 minus 1 is 4. Now rear is equal to 4. Okay, so front is equal to 3, rear is equal to 4. Someone has asked you to display the elements from front to rear, you can display the elements. Okay, is it clear? I hope you have understood. Still someone has asked you dequeue at rear, then these three conditions will be failed. This else block will be executed. So printf %d dequeue of rear. So 30 will be displayed, and then rear is becoming 3. Is it clear? Because you are calling rear minus minus. So rear will become 3. So only one element is there. This element logically you have deleted. Again, if someone has asked you to dequeue at rear, this condition will be failed, but this condition will be true. Front is equal to 3 and rear is equal to 3. So 3 is equal to 3. This condition is true. So you are displaying the element which is there at the rear in the array dequeue. So 20 will be displayed. You have logically deleted this one also. Am I right? Then front is equal to rear is equal to minus 1. So you have deleted this. So now the dequeue is empty. Already we have deleted 40. Okay. So now front is equal to minus 1, rear is equal to minus 1. Then double-ended queue is empty. So I hope you have understood all the 4 operations: enqueue at front, enqueue at rear, dequeue at front, and dequeue at rear. Is it clear? Now let me discuss about the display function. You want to display the elements which are there in the double-ended queue. Is it clear? Let me erase it properly. Okay, void display function. Okay, the name of the function is display. It is a user defined function. If display also, before displaying the element, you need to check whether queue is empty or not. If front is equal to -1 and rear is equal to -1, then you can say that double-ended queue is empty. If it is empty, how can you display the elements? You cannot display the elements. Else, then only we will display the elements. We will declare a variable called I. Then we will assign I is equal to front. Okay, because from front to rear we need to display the elements. Then while I not equal to rear, meaning is that if front is not equal to rear, okay, then we need to display the elements. So printf %d \t you can use, or \n. If you want in a new lines, in a separate lines, you can use \n. If you want in a same line with a tab space, you can use the \t. Okay, then what you want, the element which is there at the index I, whatever the element is there that you want to display, and then again you will write this statement, printf %d dequeue of I. Oh, sorry, before that I need to write an increment condition. Am I right? We written the condition and what are the statements, but we did not update it. So how we can do it? I is equal to I plus 1 modulus size. So this is your update section, because every loop will have the initialization. We have done the initialization condition. We have to do the update also. Then we have to write printf %d dequeue of I. Let me discuss with an example for better understanding. Close the else, close the display function. Let me take an example. You have elements 2, 3, 4 and front is equal to 0, rear is equal to what? Rear is equal to 2. Is it clear? This is the one scenario. Now I is equal to front, so now I value is 0. Okay, now while not equal, I not equal to rear, what is the rear value? Rear value 2. So 0 is equal to 2. No, the condition is failed. So you are printing the element which is there at the index I, which is index 0. So what value is there? 2 will be displayed, and a tab space will come, cursor will come here. Then you are writing I is equal to I plus 1 modulus size. So 0 plus 1 will be 1. 1 modulus 5, size is 5 here. Am I right? 1 modulus 5 is, modulus operator will give you the remainder. So 1 only. So I value will become 1. Now you will check the condition. 1 not equal to 2. Yes, this condition is true. So again you will display the element which is there at the index 1. So you are getting the value 3 and you are given the tab space. So you will come here. I is equal to I plus 1. 1 plus 1, 2. 2 modulus 5. I value will become 2. Is it clear? Now again you are writing while I not equal to rear, but 2 is equal to 2. So this condition will be failed. You will come out from the while block and you will execute this statement, printf %d dequeue of I, dequeue of 2, which is 4. 4 will be displayed. Is it clear? Or you can take another scenario also. You have elements like this. Rear is here. Then also this program will work from front. I is equal to 0. Then also it will work. Meaning is that, see, sorry, I want to say front is here and rear is here. Then also this logic will work. Okay, that's why I am using the modulus operator. After displaying the element 3, 4, then 4 plus 1 modulus size will become 0. Is it clear? So this is about displaying the elements which are there in the double-ended queue. I hope you have understood enqueue operations, dequeue operations and display in the double-ended queue. Now you can write the main function. Inside the main function, you can declare some variable and ask the user to enter the choice, read the choice, okay, and open the switch case, and you ask them which one you want. Case 1, enqueue at front. Case 2, enqueue at rear. Like that you can write. And already in the last program video like circular queue implementing the array, I have written the main function. If you want, you can refer that video. I hope you have understood all the concepts which I have discussed in this video. If you still have any doubts, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.